Well, welcome to the Daily Space Weather. And we've got another X-class solar flare and another major solar storm on the way. So stay tuned for more information about that. We'll be telling you when it's expected to arrive. Once again, ESA and the Smash News Network least busted name in news agrees. And here you'll see some activity kicking off here. So stop your grinning and drop your linen. We got some fresh imagery for you from the past 24 hours on the closest star. That X-class flare came from sunspot 3663, a great name for a sunspot too. 3663 is that northern sunspot group. And don't worry, lots more images where those came from. 30 frames per second, 24 hours is the time frame there. These images depict ionized iron, some very hot iron gas there in the sun's atmosphere. Here's ionized helium, 304 angstroms from Solar Dynamics Observatory. It was approximately an X1.7 class solar flare, and it was accompanied by a major coronal mass ejection, a large portion of which will be striking Earth. More will miss to the north, a lot will strike Earth. Here's 335 angstroms, yet another of the many ionized iron species that are covered by SDO. 335 angstroms is particularly good at showing solar flares. Not half bad. Not half bad at all. All right, next, let's show some slow-mos. Yeah, we made it slow-mo for you. Check it out. It was not a long duration, that's for sure. Quite an impulsive solar flare. Again, it was class X1.69 was the highest peak I could find. And yeah, major CME accompanied it, and a major solar storm on the way to Earth. By the way, if you enjoy the content, don't forget to press the like button. Tell your friends and foes about the channel by pressing share. Visit us on social media. Don't forget to visit the homepage, smashomash.com, and welcome to the Neo-Renaissance. Congratulations on realizing the channel exists. Press like, subscribe, share, leave a comment, etc., especially if we've made you mad about something, because a lot of people have been very mad about facts. And a lot of facts have been controversially stated on the channel. So yeah, check out our homepage if you haven't. You can find original music there and all kinds of additional content on social media, exclusive content across platforms. Smashomash.com is the homepage. So the Reconnaissance Peninsula has been featuring some magma motions, not looking all that likely that an imminent eruption is in the cards. Abiko is erupting, though. It's producing a 14,000-foot ash plume. Luotobi, Semaru, 14,000-foot ash plume. Flight level 060 over Ruang as it calms down. Fernandina, congratulations to Ecuador. As your nation is growing in physical size, Fernandina creating some new real estate in the gobbledygook Galapagos Islands. Popocatépetl also exploding along with Sancho Guido. Let's don't forget Fuego and Poas in Costa Rica. Also Sangay in Ecuador exploding. Also Revenador exploding. And Sabancaya in Peru producing a 23,000-foot ash plume. That's a flight level 230. Please do not pole vault the caldera. Please do visit the links below the video and perhaps pick up some fresh merch and be 70% hot and 30% mess, just like me. Pardon the magic shirt. Once again, I've got space on my case. I'm a space face. Next is earthquakes, and no major quakes over the past 24 hours. Let's see what's been shaken of a 5 or greater magnitude. Kermadec Islands at a 5.1. Near Vancouver, we had a 5.0. Check it out. At Tofino, Canada. 5.0 there off the coast of Canada. Philippines had a 5.7. I think that's the largest quake of the past 24 hours. 5.7 occurred at 10:16 Universal Time this morning. Since then, things have calmed down a lot. although South Sandwich Islands had a 5.1. It's been a seismically calm 24 hours. As far as the radial flux goes, I don't know what it is. It's 142, so we've been seeing the sunspot number and the radial flux come up. The 10.7 centimeter radial flux discovered in 1947 by Canadian World War II radio equipment users is the most proportional data set we have to sunspot number. So it's very important to the analysis of solar sunspot cycles. It is emitted from the upper chromosphere and lower corona, and it is associated with uptick in sunspots, uptick in radial flux. These things are directly proportional, as you should be able to see by looking at that graph, which depicts the radial flux as the black line and the sunspot number as the red line. Sunspot number average now up to 170. That's the 30-day, that's the Wolf number, which is a 30-day smooth number. Yeah, 170 sunspots is now the average. Space Weather Enthusiast dashboard here showing no signs of geomagnetic storms in the forecast. That's going to be changed by tomorrow, because May 5th into May 6th, which would be Sunday night into Monday morning, we're going to have a major geomagnetic storm. That X-class solar flare was associated with a high-speed coronal mass ejection. Again, we'll get to it. And here's NOAA's rather wishy-washy forecast about it. It's looking like it's showing a coronal hole high-speed stream there at the same time. I don't know. It's sometimes you look at NOAA's Enlil spiral and you just have to say, I don't know. I don't know what they were thinking. Maybe they'll change this, but they are showing most of the CME to miss Earth to the north, which is largely correct. It's just that it looks like it's showing two separate events there, and I don't think it's correct. So now ESA's Enlil spiral is looking a lot more reasonable here. Still a glancing blow impact, though, so this one might be a lot stronger than what the forecasts are calling for, folks. So, hey, we just had a KP7 and nobody was expecting any geomagnetic anything, because most channels that cover space weather don't forecast anything. They don't forecast anything. Anyway, here are the past 4 hours of Earth's magnetic moment from space. We are in a geomagnetically calm situation right now, so there is a bit of a heightened solar wind velocity from a coronal hole high-speed stream that was showing up right as the CME impact was ending from yesterday. We'll get to it in the solar wind analysis. Here are the last 4 hours of Earth's magnetic moment from the ground level. Ground magnetic perturbations map depicts changes in magnetic flux density to Earth's B field. A B field is the field that goes through the magnet, that magnet being planet Earth. And no, the pole shift isn't scary in the slightest. It is irrelevant from a geologic perspective. Next, the KP index, which is at 1. KP1, it's calm. We have elevated solar wind velocity, but not much else. So right in here, let's bring this to the full screen mode. So right in here is where the CME impact subsided. But at the same time, we had this characteristic feature of coronal hole high-speed streams. So the coronal hole high-speed stream was cooler, but also faster and less dense than the CME impact. It was also accompanied by a pretty uninteresting series of magnetic fields. So there you go. That's what happened. We are seeing a weak coronal hole high-speed stream right now. The ACE and Discover agree. We'll call out the numbers for the Discover, but you can see the same scenario happen. So the density dropped while the velocity came up. So as that CME subsided, coronal hole high-speed stream arrived. Although that's now rapidly subsiding as well. So solar wind density out at Discover is only 5.4 protons per cubic centimeter. And solar wind velocity barely over 400 kilometers per second. GOES magnetometers have smoothed out since that 6-hour-long KP7 situation has subsided. And yeah, another great CME on the way It's good news for aurora chasers. Next, the heliosphere magnetism. We're looking at the magnetism of the heliosphere. So Earth is remaining right now in a North Pole-oriented magnetic sector. There's the current situation, and we're several days out, assuming nothing changes. It looks like the North Pole coronal holes have won the tug-of-war. We'll get to that after we show this, our line-of-sight field plot, showing the photosphere magnetism, the solar B field, and the solar polar fields, all at once for the past 4 days. Which brings us to coronal holes. Here's our coronal hole line-of-sight field plot, and we've got, as you can see there, North Pole coronal holes winning out in the east. So check it out. If you bring up the last image, we've got nothing but North Pole coronal holes. So keep in mind that could change rapidly with absolutely no warning. So don't be surprised if it does. And here is our 24-hour video at 211 angstroms, the optimal wavelength to view coronal holes from Solar Dynamics Observatory. Another species of ionized iron, the corona. It's a rich chemical soup. And we'll show you even more chemical spectra as the video progresses. We'll move on to sunspots next. So here's a sneak peek. There you go. All right, so sunspots. Sunspot number now has risen back up over 150. So the monthly average for April was about 130. And of course, the rolling average is actually 170 now. So there you go. The monthly average as well. The monthly average is coming up, and the rolling average is now coming down a little bit. But yeah, so 150 sunspots has been exceeded once again. And as far as the flare probability goes, 3663 remains not only the T-mass, the most active sunspot, but the most likely place to see additional large solar flares. It's quite unstable up there. I'm looking at it right now from the GOES 16 SUVI, which is on the other PC right over there. And yeah, we're streaming to Twitch, by the way. Streaming to Twitch, you can find it on smashomash.com/smashteam. Links on the homepage at smashomash.com. We stream it pretty much 24/7, give or take. So yeah, the likelihood of a large solar flare from those setting groups in the southwest has subsided, but replaced quickly by sunspot 3663. Anyway, getting back to there we go. You've reached the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. So that's our SDO continuum. It looks like that sunspot has actually grown a little bit since yesterday. And as you can see on the magnetometer there, the SDO HMI instrument magnetometer showing that, yeah, there's still significant magnetic shear there. And like I said, that sunspot remains the most likely place for a large solar flare, including additional X-class events are possible. Fingers crossed for that. And let's look at ionized carbon as well. There's carbon that's 1600 angstroms. And you'll see a lot of white popping up around when that X-class flare occurred. Let us know in the comments where you think all of that carbon came from. Was it just hanging out and it just happened to get ionized to those temperatures as a result of the flare? Or was it some other process at work? And just keep in mind, your opinion may be controversial on this. Yeah, you may be saying blasphemy in our comments, depending on where you think all of that carbon came from. So when you see that lighting up white like that, that means that that is maxed out. There is a lot of carbon in those areas. It's a specific species of ionized carbon. I don't know exactly which number it is, how many electrons it has in its shells, and so forth, but 1600 angstroms is the wavelength. It's part of the extreme ultraviolet light spectrum. And teaser, solar flares are next, right after energetic particles. So, hopefully your drawers haven't developed any sharticles as we look at energetic particles. So the ghost proton flux here, still flatlined. No SEPs for quite a while. As far as the X-ray flux goes, like I said, 1.7 was the class of that X-class flare. Peak flux was at around 2:22 Universal Time this morning on May 3rd. May 3rd. And it's time for 94 angstroms. So there's another 24-hour video for you there. Not half bad. And here's another extreme close-up of Sunspot 3663. By the way, if you're trying to equate the intensity of a solar storm with the intensity of a solar flare, you shouldn't. That's a very silly thing to do, because solar flares and CMEs are completely separate phenomena. You can have a CME without a flare, and you can have a flare without a CME. So to suggest, as I've heard certain people who cover space weather on YouTube, that the intensity of a geomagnetic storm has something to do with the intensity of the solar flare that it was associated with, and that's got nothing to do with reality. That is fakeality. That's not how it works in the slightest. Let's move on to our solar system forecast. This is where things are today. There's where things will be in a week on the 10th. Here's what's going on over my head. Mercury is setting, chased by Venus, chased by the Sun, chased by Jupiter, across the ecliptic. Today's apod.nasa.gov is a very steamy place. It's very steamy. I wouldn't recommend you go to that place, as you would suffer significant steam burns. Yeah, there's water in the atmosphere, and it ranges from 1,000 to 2,500 degrees Fahrenheit. Yeah, it orbits pretty closely to its K-class, its K-type parent star. And yeah, there's an article there you can read about it. It orbits its star kind of like the moon orbits the Earth, where it has a constant day side and a constant night side, but there's circulation happening with convective currents and so forth there that are transferring a lot of that heat to the nighttime side. So not a good place for a vacation. It's a little bit too warm there to be hospitable. There is water, but it's, at least at the surface, between 1,000 and 2,500 degrees Fahrenheit. Not something to dip your tippy toe in, because your tippy toe would vanish as if chopped off by a lightsaber. Next, CMEs, and there you go. Early this morning, one was directed toward Earth, and it's high speed, which is why it's going to show up a little earlier than they usually do. It's very obvious that it's high speed. You can see right there in the imagery that it indeed is faster than most CMEs that we cover on the channel. Let me bring these back and show them to you in their slow-mo glory. So bringing this back, there's the LASCO C2, and early this morning, kablooey. It might not look like much, but keep in mind when diffuse gas is headed directly toward you, it can be a little bit deceptive. That is a partial halo. Stereo A got some great imagery of it as well. That's where Stereo A is located, and unfortunately, as you can see on this image, we don't have the Solar Orbiter or the Parker Solar Probe or Bepi-Colombo in between Earth and Sun to measure the CME. So, you're on your own. You're on your own, relying on channels like ours who make sense and make accurate forecasts. By the way, it turns out that is Jupiter. Stereo A has a page that's specifically to show what planet, and I think I mentioned it yesterday, but in any case, let's do the difference imagery first. We'll move this forward to this morning's CME festivities. And there you go. You can see most of that ejecta is slightly off to the north, but it is a partial halo there, even at Stereo A's difference imagery. So good stuff. Another major CME on the way. And there you can see Jupiter appeared there sometime around the 29th or something like that on the stereo A coronagraph. I don't know why it's so small. And before we get to filaments, let's take a look at CMEs from our custom. Dag! Not half bad. Not bad at all. It's a 24-hour video there, SDO in the middle, with the LASCO C3 in blue and C2 in red. Here we've zoomed in and added 193 angstroms to the SDO imagery. And you don't really see a whole lot going on with that filament release. Again, it can be very deceptive, but there is certainly quite a bit of plasma on its way to planet Earth. And it's time to blast through our bonus feature segments and meteorology. So starting out with bonus features, plasma filaments. The Charles Barkley filament down there in the southern hemisphere remains intact. If you want to name filaments, follow us over on Twitter, x.com/SmashOmash. You can also find our links to social media on the homepage at smashomash.com. Next, the past couple of hours there from the GO 16 SUVI, and it is quite unstable there in both the eastern portion of the sun as well as that north-central region. Sunspot 3663 is good stuff. Here come bonus features. Satellite charging hazards are non-existent. The GOES electron flux remains very low following that geomagnetic storm. That has not subsided yet, still anomalously low. There's the one-year graph of the electron flux, and we're in a major trough, as you expect when you see CME impacts. There's NOAA's forecast for the relativistic electrons. And here is the layer, the F layer, in its vibrational frequency. And you'll see a lot of low-frequency anomalies showing up here, as, again, we did have a KP7. So that is a significant geomagnetic storm, a G3 class geomagnetic storm. And it did last about 6 hours, sometime under 6 hours. But, yeah, major effects continue. That will subside over the next 12 to 18 hours. So by tomorrow's Daily Space Weather video, you'll see a lot less red on this map, the anomalygram depicting anomaly in megahertz from a 30-day median. We got to close out space weather here, as we've got plenty of meteorology stuff to cover as well on today's content. So there's our total electron content and maximum usable frequency. The global ionosphere nowcast, or WHAM, the whole atmosphere model. And I seem to have vanished. But now I'm back. So that's what's going on to about 12,500 miles of altitude on the left and to the ionosphere on the right. Here's the latest. And again, major magnetic shear right in the middle of that sunspot. Look at that. That is an X-class flare waiting to happen, folks. That is major, major. What is it major? It's a major, major X-class solar flare watch, in effect. Don't be surprised to see one happening in the next few hours with that configuration. That's a good one. Let's get to meteorology. Check it out. There's a bunch of Saharan dust in the tropical Atlantic. That's going to tamp down tropical systems to start out the system, to start out the season. So for early May, don't expect to see much popping up there in the tropical Atlantic, as that is a lot of dust, which tamps down weather systems. So for all of you weather Armageddon TV evangelists, YouTube evangelists, sorry, don't expect any tropical systems coming out of there for the next 5 to 7 days, at least. Anyway, surface winds and jet streams are next. Surface winds of the east and the jet streams. Central world's jet streams. Surface winds. Surface winds of the west, jet streams of the west, satellite imagery of the west. How refreshing is it to have access to such fantastic imagery? Anybody who complains about that has got something deeply disturbing wrong with them. That is freaking awesome. And look at the turbulent weather around Texas once again. Now we're just showing surface winds and pressure isobars. One of the many features of Windy.com's mobile app. You can download it for free, Windy.com. Fantastic. Weather.gov is next. And again, we've got severe weather around especially Texas. Lots of weather warnings. Weather.gov is where to go to get your warnings. Here is our pressure and precipitation forecast for the next 3 days or 72 hours. GFS model, 72-hour pressure and precipitation. It continues to snow in some parts of the country, and California is going to have some areas that are getting over a foot in the coming 3 days. There you go. 72-hour positive snow depth change forecast in inches. Dag. Also some heavy rains coming to the Pacific Northwest and to central Texas. Also northern Louisiana. Well, there's the map. 72-hour accumulated precipitation forecast in inches. Also winds. It's going to be very windy in the southwestern part of the country for days. So there's our pressure and 10-meter wind speed forecast on the same model. Lots of blowhards in the state of Colorado, that's for sure. And here is our jet stream forecast. The 250 millibar winds, GFS 72-hour model. Pretty incoherent jet stream coming to the east, although there's one pushing through. The next 3 days, it will cross the Rockies. Temperature anomaly forecast in degrees Celsius for the same model, GFS 72-hour. And look at that, all that hot air in Colorado there. It's going to be cold, anomalously cold, primarily west of the Rockies. And more average east of the Rockies. Next, lightning. Again, we've had some very heavy systems across Texas and the Gulf states. Here's a real-time lightning map from lightningmaps.org. Lightningmaps.org, powered by blitzoltung.org. Highly recommend it next time you hear thunder. No major systems, but quite a bit of scattered thunder showers across the U.S. Here's our Doppler map, displaying vertical motion in the air column. Vertical motion of things like water droplets and ice crystals. And in some places, meth crystals. Hopefully not fentanyl crystals. And here is our satellite map. Look at the rapid cloud nucleation happening there over northwest Texas. There's a huge pressure gradient right there, causing clouds to form rapidly, and people to believe untrue things about how weather works. They'll swear it's man-made. Note how much moister the air is north of that system on our water vapor map. Anyway, here's your recap as we dispel nonsense constantly on the channel. So much nonsense to dispel, so little time. Once again, satellite imagery and water vapor. When your Doppler's unclear, try the water vapor map, part of the NASA Goes Interactive Weather Satellite Suite. And here's me signing off. Until next time, may that solar wind be at your back, while I go back to the bunker again. Whoa!